There we go. All right. Hello, everyone. Thank you very much for coming along today. This is going to be our last STORK seminar of the summer, as we're going to take a break for August. But I think we've picked a really fascinating topic and a really great speaker. So I think it's going to be a great one to finish off the STORK summer series with. So today, guys, we've got Professor James Betts from the University of Bath. James is a professor of metabolic physiology. His research primarily focuses on how different feeding strategies can impact metabolic regulation. He's also the editor-in-chief of the International Journal of Sports Nutrition and Exercise Metabolism, and is the lead author on the present 2020 checklist for research reporting in sport and exercise trials. And that's going to be the topic of our discussion today, is on research reporting and the design and implementation of this checklist. So James, thanks so much for agreeing to come along and talk to us here today. Really looking forward to hearing what you have to say. So thank you, and I'll pass straight on over to you.
Well, thank you for having me. And I think I was very interested to hear what this society is all about. I think this is obviously something that's close to my heart and important for science, which is partly what we were trying to achieve with that present checklist. So I'll get straight into it. I didn't really know what to give as a title, but I figured that research, design, conduct, and reporting kind of all comes together. It's kind of all things research. And as you heard, then we're really thinking about basing my talk on this paper. This was the present checklist, which we published at the start of last year. And the rationale behind this, I'm well aware that there's plenty of checklists out there, plenty of guidelines out there, and we're not trying to step on anybody's toes here. But I did feel that, particularly in my role as the editor-in-chief at this journal, that there were many common pitfalls in terms of design, in terms of statistical analysis, and in terms of reporting. And, you know, if there's a problem with the design of an experiment, there's often nothing you can do about that after the fact. But in terms of reporting, there's really no reason for some of these things to go missing and just be left out details of papers. So when there were so many common issues, I thought, well, I'll put the whole editorial board here, who are all authors on the paper. Particularly myself and Javier Gonzalez at Bath wrote a lot of this, and Greg Atkinson, who was the senior author at the end there, did a lot of the work on the statistical analysis side too. And the consort guidelines, I'm sure many of you are familiar with, those were wonderful guidelines, and I'd always used those myself, but I'd felt that a lot of the aspects in there are meant to apply to a wide range of research, and particularly clinical trials, medical research. And that's fine, but I felt that the type of designs we often have in exercise science or kinesiology, we make much more common use of crossover designs. And there's some specific issues pertaining to crossovers that you don't get in parallel group clinical trials. And we also have other considerations which you don't have to think about, or think about less in medical trials. There's issues specific to working with athletes. A particular issue I'll focus on today is order effects, the carryover from one trial to another. And in medical research, that is often only considered in relation to the treatment. So if you give a drug, you want to let the drug wash out before the follow-ups. Whereas in our research, as many of you will be aware, the treatment itself washes out very quickly. But whether you've done a VO2 max test or a muscle biopsy, it's often our actual measurements that carry over from one test to the next, not the intervention itself. So those are just a couple of the issues I'll focus on. And I can't cover everything we looked at in the present checklist, but luckily it's published. So if you want to see all of the issues, then please do. What I have done is made a selection from the standard sections shown here of introduction, methods, and so on. And I'm just going to pick out several points from each of them. And what I think I may do, I believe that we have the opportunity to try and make this session interactive despite being dotted all over the place geographically. If I remember, I'll try and see if we can do some Q&A and discussion after each one. So on just the title and the abstract, although there are only a few words, more people, you know, it's depressing when you've written your paper, but the fact is more people read your title and your abstract than read the rest of it. So causality, context, and data I'll talk about there. On introduction, I'll talk about balance, novelty, and importance. On methods, the three key issues I want to cover are consent, power, we mean statistical power there, not watts, and sampling. In terms of interventions, I'll cover controls, randomization, and blinding. And then hopefully I won't be running out of time. We'll cover on analysis, reporting generally, and then order effects and within group tests. There's so much I could cover on statistical analysis, but I'm going to pick out just those two as the major pitfalls in our area. And then in terms of discussion, just a couple of things I think are important about internal and external validity and limitations. So starting with this top one on title and abstract, and some of these I've got a couple of extra slides to go with them. I don't really like having a lot of stuff on the slides, so I'll really just talk around some of these. In terms of the title and abstract then, as I said, I think these are some of the most important aspects of our paper. Causality, I could raise as a point in relation to all the sections of the manuscript. A really common issue that I see when reviewing papers as an editor is cross-sectional or observational research making use of causal language. So I think if you are describing your research as observational, just do a search document before you submit to make sure you're not using any words like increase or effect or results in, because we shouldn't use that language. And often journalists pick up on that, and then they will report your paper as a causal study. And again, sadly, more people probably read the journalist's version of your paper than read the scientific version. So making sure that we use appropriate language in the title and the abstract is critical. Non-causal language if it's not a causal study. The context, what I mean there is be clear on the outcomes we're talking about. If you've measured blood glucose concentration, say blood glucose concentration. Don't talk about insulin sensitivity. Don't talk about glucose kinetics. Just tell it like it is. And that goes for the model as well. If it's a non-human animal, then say so. If you've used men and women, then say so. That's important to come through in the headline. And last but not least, I think I meant to put that in block capitals, data. The number of abstracts I see which don't report any results. I think if you were going to tell people one thing about your study, you want to tell them this amazing thing you've found. And so many abstracts tell us, this is why we're going to do the study. Here's what we did. And then doesn't tell you what the numbers were. And by numbers, I don't mean p-values. That's useless just knowing A was greater than B, P equals 0.05. We need actual numbers in the abstract. And that's especially true at journals where the paper is behind a paywall, because more people will only be able to see the abstract, especially journalists and the general public. So just as a reminder to myself, I always think last step before submitting the abstract is, have we actually got some numbers squeezed into that normally quite limited word count? So I think that's all I wanted to say about the title and abstract. Because that was quite a quick section, I probably will just jump past any kind of discussion on that and go on to the second one, and we can then maybe see if there's any comments after that. On introduction, the three things I wanted to cover was balance, novelty, and importance. So this picture of a lemon here is to remind me, this is what I always advise everyone working in my lab to do with an introduction, is it should be lemon shaped, as in it kind of starts with a nice pointy end, as people should pick up in the first two lines what the problem is, what the question is you're dealing with. Then the whole thing fleshes out into wider and wider context. You're taking in the full balance of what's been done before, talking about mechanisms, introducing the supplement or exercise model you're interested in. But then just like a lemon, it starts to focus down again, so that by the end, it's really clear that, well, this is the niche that we're interested in. And I think that's what I mean by novelty and importance. Any of us can design a novel experiment on the spot. We could ask, do people called James respond to lemon ingestion on a Wednesday? that probably hasn't been published before. I haven't checked it in PubMed, but it's likely to be novel because it's so specific, it's not important. Whereas if we ask a really important question like, what's the best diet to treat diabetes? Well, it's undoubtedly important, but not so novel. We don't have an answer to that, of course, but many people have tried already. So I think the key thing, as an editor at least, I'm looking for, and what I try to do in my own research, is to get across, this is what's new, and this is why that new thing is important. And I think a bit that is especially relevant to kinesiology here is we often see the novelty depending on the specific context of the experiment. So we will have researchers saying, well, you know, we all know that carbohydrate improves performance of a certain event, but this hasn't been demonstrated in elite cyclists from Peru. And I think, well, that may be true, but we need to then provide some rationale as to why we think data won't generalize from other types of cyclists from other regions. So sometimes the introduction needs to get across why that study is important. And again, I think a lot of papers, you read the introduction and it looks like this is the first ever study in an area, but then you come to the discussion section and the study is suddenly contrasted with 10 other very similar experiments. And I think it's important that they come at the start to let the reader know what really is the novel advancement in this study. So yeah, I don't know, maybe that's just as a quick opener on those first two sections. Are there any questions so far? There may not be because I haven't said too much yet, or aside from questions, I'm keen to hear any other opinions on this. Maybe also opinions on whether we think you should have a hypothesis nowadays. That's always the advice from professors, will say, oh, you must have a hypothesis. And I don't know whether everybody agrees that that's really what we should be doing anymore.
We had a really interesting journal club discussion on that quite recently. I don't know if people are aware of Anne Shields' recent paper on why hypothesis testers should spend less time testing hypotheses. And it was a really nice paper and an interesting discussion. James, we've already got a couple of questions popping up in the chat. Actually, one of them.
I can't see that, yeah.
I can shout out, well, actually, the first one was from me, so I'll just shout out my own, and then we've one from Jennifer here as well. I'm really keen to yours or anyone who's here tips on, I fully agree with your recommendations about avoiding using causal language for non-causal studies, but I sometimes struggle with it in practice. And I wonder if you have any tips or examples on appropriate kind of language swaps that we can use to more appropriately convey uncertainty in more, say, observational or exploratory studies, but without completely explaining away your studies. I sometimes feel like I go the opposite side, and then so, well, maybe this means that, but maybe not, that I actually end up not coming to any kind of conclusion or have a very unclear message. And I wonder if you have any thoughts on maybe simple language swaps. Instead of saying we saw an effect or we saw an increase, what kind of language would you recommend?
Yeah, the word effect is a tricky one because sometimes people mean effect size as in cause and effect, but I tend to make sure I'm using the word like related to or associated with, or just use the term correlated with rather than caused, resulted, increased, or anything like that. Risk of is another really tricky loaded one, because if you say, well, this increases lifetime risk of this, I think people do read that and think that we're having a causal inference there, that you do one thing and it increases your risk, rather than the fact it could be reverse causality or completely unrelated variables.
Yeah, it sometimes feels like the more you get into these things, the more it all words are so loaded that somehow you end up with an introduction entirely on definitions and you've not gotten to your study. So it can be tricky to get that balance, but good tips there. A question here, can you discuss the decision not to require study design reporting in the title and or abstract? Or is that
so not having to state that it's a randomized control trial or anything. So I think I personally, when I report a paper, I will make sure I get those words in there, because I think if you've taken all the steps to make sure a trial is randomized and blinded and so on, then you really want to say that in the abstract. However, as I'll come to 2 points down, randomization really isn't as straightforward as was this trial randomized or not. I mean, many people don't realize it, but you think it's a randomized trial, but almost everything we do is some form of pseudo randomization. So I think if we put in a recommendation that you must have the full detail of your design in there, other than just saying whether it was a crossover or parallel groups, people would use 50 of their words in the abstract, just getting across the complexities of that. So that was why we decided to leave it out. But yeah, I'll come to why I get so confused, because I certainly always felt like during my PhD, I was like, well, you either randomly allocate or you don't. But I've since realized that it's a bit more difficult to do that, and realized I've never really done a randomized trial, I don't think.
I'm finding that with basically every element of study design, etc. I think a lot of things I thought I was doing probably wasn't doing at all. Cool. Vanessa has shared a table with some useful words and swaps kind of terminology. But if no one else has any questions for the moment, James, you happy to carry on?
Yeah, okay.
Awesome.
So, how do I do that? So yeah, on to methods. And the three things I've pulled out is consent, power, and sampling. And the consent one was tricky. I mean, I think there's still a bit of a mixed message in our present checklist. And that's because several of the editors had different views on what was okay here. You, again, can make this very binary and just say, well, you should always have consent from participants in research. But then if you're actually living in the real world, you realize, well, actually, there's plenty of situations where that doesn't occur. That can either be through, I'm a chair of an ethics committee as well as doing the editorial role. And there's plenty of examples where deception is really quite justified in research, and there's ways and means to manage that. So we can't just say, as some leading sports science associations do just have that hard line, that if you want to be a member of their society, you must agree to always have informed consent from participants, which is a nice sentiment. But as I say, there's situations where we, to blind an outcome, have to look for consent post hoc, maybe do some covert monitoring. The more complex one still, I think, is many of us are lucky enough to work with elite athletes or even military populations who take part in physiological research as part of their employment. So even if we have them fill in a consent form, there's a question as to whether they really had an option to say no to that, or whether they're, even if they said no, would they be providing the data anyway, and then we get it anonymized. And so we've had some recommendations in our journal for how to deal with that, but I'm still not really decided how I feel about that, because while I accept that you can't just say you have to have informed consent for all research before it's done, I can understand why we might want to not put a foot on that slippery slope, because there's all sorts of horrible things can happen once you stop taking consent. So I guess we may have some discussion on that, and anyone who works with athletes might have some insights on that. Linked to that then is about statistical power and how we decide how many people we want to be in our study. And that can be difficult. And especially, again, in the kind of studies we do in kinesiology, because it's not like if you're sending out a survey of physical activity where you can say, well, let's just send out a few more. If you're taking muscle biopsies, it would be really unethical to take twice as many as are necessary to answer the question. And then equally, we sometimes have quite specialized populations. Again, I'm thinking of athletes here. If you need particularly well-trained individuals, is that a justification to have a suboptimal sample size? And I'm not quite convinced of that. I think the word elite gets used a lot in kinesiology. And sometimes I think, well, are these really elite athletes in all these studies? But then even if they are, this kind of links back to introduction. I think if we're saying, well, a novel aspect of this study is that we're using elite athletes. Well, if you're telling me that the thing you're measuring is cycling performance over a week, and you've got the best 10 cyclists in the Tour de France, I would agree that they're elite. And I would agree that those 10 individuals are significantly different from the next tier of athletes we might find, of regular cyclists. Some studies, though, will say, well, we use Premiership footballers, but we're measuring sprint times. And I think, well, they're not playing in the Premier League football on account of being good sprinters. It's a part of what they do, but we're not actually testing them on the attribute for which they're classified as elite here. So I think if we're going to say we're avoiding standard kind of power calculations for our statistics by saying these are elite athletes, I think there needs to be a good case for that, really. And then last but not least is this issue of sampling, and that I do have a separate slide on, because before we get into randomization, we need to think about the other random aspect, which is whether we have randomly selected the group for our study. And there's just a few of the different examples of random sampling, stage sampling, cluster sampling, so on, listed on this slide. But actually, we almost never use any of those in our research in kinesiology. We don't get to do a VO2 max test on everybody in the population unless you're interested in a very focused population. We almost always are using opportunity sampling. We either happen to have access to an athlete group, or you can only take blood samples from people who are willing to have blood samples drawn from them. So, we don't always get a random sample, and we need to think very carefully about whether that poses a problem for our research. When I'm doing a study and looking at gene expression in adipose tissue, do I think that the individuals who are willing to have an adipose biopsy are likely to express their genes differently than the people sat at home who are scared of needles or just don't want to take part in research? And I don't think there's likely to be a difference. There may be, but I think we can probably generalize. If, however, we're looking at a survey of sports nutrition supplements, then I really do believe that the kind of people who volunteer to fill in a questionnaire about attitudes and knowledge of sports nutrition probably have a better attitude or a different attitude and are more knowledgeable about sports nutrition than the people who didn't even see that poster when they walked past it because they couldn't care less. So I think this is a very difficult issue to manage, but I think it's really important if we're looking at the kind of sports and nutrition type research where we're interested in those opinions. And again, I'm not sure what we can do about that one. It doesn't mean those questions aren't important to answer, but I don't know how we answer them without getting a self-selected group. So yeah, I was coming on to my next section then. So I don't know, are there any questions? I still can't see the list, sorry, but are there questions on consent power sampling or any other comments anyone has?
Everyone feel free to, I'm keeping an eye on the chat here so I can read things out, but also feel free to unmute yourselves. If you don't mind, James, I'm going to jump in again though. Sorry, I tend to talk too much. I think it's really interesting. It's something I've been thinking a lot lately about when you mentioned about power and determining your sample size. And I think this almost links back to the earlier point you made. Are we actually, we all think, should we be doing kind of more confirmatory hypothesis tests? Is that actually what we're doing? I feel like the more I try to study and learn about determining sample size, the more I realize that my own studies are woefully underpowered for what I actually want to find out. And the more complex, it seems to get more and more difficult. But then I wonder, for a lot of the things that we're investigating tiny samples. And like you absolutely pointed out, it can be quite difficult to get the samples necessary to take biopsies, etc. Do you think, what are your thoughts on conducting studies that are potentially undersampled, but if the only alternative is potentially to give up on the idea? Is some data better than no data? Is it about the terminology that we use to describe what we've done? Because it just sometimes feels like the best option is to give up on the idea, which I think is certainly not maybe the best way to move forward. And I just wondered, have you any thoughts on that, where technically we need massive samples that are just beyond our resources? We just sometimes don't have the resources to do what the statistics say we should do.
So I think if we're being presented with those two options of either do a woefully underpowered study that might be of little value, or give up, then if those are the only two options, I would give up on it. And I have had some research ideas where I just think, oh, well, that's going to take such a big coordinated effort that there's no point in me doing a study on that myself. But I don't think those are the only two options. I think that big coordinated study is in the middle. And that's, I guess, exactly what these kind of collaborative openness in science ideas are about. I think there are some questions like that where I can do a biopsy study with 10 or 20 people, but so can you, and so can the next person, and so can the next person. So what I would hope in the ideal world would be is if we identify those questions, you know, if some of us are applying for grants saying, you know, I'm going to test 20 people, but I'll give an open invitation. If you give me this £1 million, $1 million, whatever, I will, you know, seek out several other labs to do as well. And then those are stronger data, right? Because then we've got independent verification of the findings as a group sample. So I think there are certain examples where that's the case, but there's also a lot that people can do when you have a study in your own lab where you think, well, I'm going to be woefully underpowered. I think that links on to sampling in that, let's say we wanted to do a study on an exercise intervention. And we said, well, I'm going to do my study in, and this is one we did back in 10, 15 years ago in Bath. We tested middle-aged men with a very, very tight range of BMI in the overweight category. We made absolutely sure that they had a specific set of health conditions and not others, and that their physical activity was in a very tight window. And some then criticized that study and said, well, this isn't generalizable. It's not a representative study. We're like, no, but you know a whole lot about that one small group now where we had quite homogeneous results. And if you want to find out the comparable finding in more lean people or older people or females, then do that. And actually one of the editors at the journal wrote a really nice editorial called Yes, Yes, IL-6, What Else? Where they highlighted that and said some people might think it's a limitation that this is such a homogeneous group, but maybe that's what we should be doing and all have a much more specific group. So you don't get to generalize so broadly, but you do answer the question about a small group.
That's actually something I fully agree. Sometimes just answering a simple question well is probably much better than attempting to answer a broader question partially. I wonder, do you have any thoughts, James, your experience as editor-in-chief, as a reviewer, as an editor, as a writer? I'm kind of keen to, moving forward in my studies, to try to do simpler studies that I'm more confident I can actually get an answer to, than to expand into more complex studies that I'm not sure I have the resources to run. But I wonder, from the point of view of within the journal, how is that viewed? How do you feel moving forward? People will view, if somebody's saying, right, I've got this very narrow study that I'm going to do a lot. Will it impact kind of moving forward if you're kind of pitted against? Sorry, I'm not choosing my words well here, but
I would hope it doesn't affect things at the journal. It's something I've been thinking about when you apply for research funding, that because you've got to get past normally kind of 5-6 reviewers and then a panel, and if there's one thing one of them doesn't like, you won't get the money. It does make me wonder whether that whole system, while it's rigorous, means that more simple studies are more likely to get funded because there's less to have an issue with. Whereas more complicated stuff is less likely. So if I'm honest, some grants I put in, I simplify, and then once we've got the money, I might add in some more complexity as is permitted. But yeah, I would hope not with the journal, and I review all the papers when they come in the first instance. So I wouldn't reject anything for being complicated. I definitely prefer things when we've got a clear answer though. So yeah, as you say, as soon as you introduce another variable to make an interaction 2-3 way, or if there's another factor comes in the study, that's all just increasing the complexity, decreasing the statistical power, and might mean you need more participants and there's more problems overall. I'm wary of time. So we're half past now. So but I'm about halfway down the bullet points there. So maybe we're okay. So controls, randomization, and blinding. Well, the only thing I was going to say on controls, because there's a ton of things I could say, the one I was going to pick on, which maybe I shouldn't in the interest of time, because it's an absolute minefield, is how you control, or whether you can even control, for menstrual cycle. And I'm by no means an expert on this, which is why I've just struggled with it so much, I think. But this is really tricky, because many studies supposedly don't control. They just ignore the fact that menstrual cycle exists, which, like many of the things in research design, is maybe a bit paradoxical, that we'll go full circle and say not controlling for it is something that's wrong. And then when we think about the ways you may or may not control, you realize maybe not controlling is the way to go. Because then some studies control, I suppose the next step up is to control within each participant. So if you've got one female doing two conditions, then they make sure that they're both in the same stage of whatever cycle they have, around 28 days. So if it's on day 10 both times for that person, but another participant is day 20 both times, and you've got within subject control. And then it's often viewed that, I don't know, a better way is to do between subject control as well. So we then say, well, every participant, we often have done this, every participant is between day 3 and 7. So we think this is follicular phase. And I think, well, that's lovely. But then the reason we often choose follicular phase is because a lot of the female sex hormones are lower at that point. So we have rightly this push in research to say too much research is done only on men. We must test women. And then we test women at the 1 week in the month when they're most like men. So again, we may have come full circle and said, it's actually important to make sure that women are tested at all times of the month, and then you get a representation of females overall, and a decent comparison and contrast against men. So yeah, I won't say any more about controls at all, but I'd be happy if anyone could advise me what the best thing to do there is, because we've either just monitored it or tried to standardize within or between, and none of those are ideal. And you don't want people to fall back on saying it's so complicated, I just will only test men. Okay, on to the other two quickly then. Randomization. I'm going to jump this slide. This is just showing that correlation does not imply causation, and we don't need to be reminded of that. This series of papers, if anyone hasn't read them, I would definitely recommend them. They came out, luckily for me, during my PhD, and this series from Charles and Grimes in the Lancet really is a wonderful breakdown of all things randomization. Randomization is a beautiful thing. It seems so obvious nowadays that if you randomly allocate people to groups, then you make your two groups, according to probability, if you've done it with enough people, then all the variables you can think of and measure should just end up by chance fairly similar between groups. And even the variables you're not aware of yet, or might, there might be something we only learn of in 10 years' time, and that should be equally distributed too. So it's strange that people have only really been randomizing people into trials for under 100 years. And like I said, my first impression was, this is simple. You've either randomly allocated, so if we toss a coin, then you've got a 50-50 chance of going in treatment or placebo, and we get a randomized group. But it's not that easy to do. If you do just toss a coin for 10 people to put them in groups, you're going to get a 7-3 split or worse, something like 10 or 20% of the time. And we don't want to have an underpowered study with one group with not enough people in your exercise intervention, say. So we end up using strata, block sizes, minimization techniques to keep our groups more balanced. But all of that then does come at the cost of compromising to some extent a true randomization. Then we have to think about all these other factors about whether we're blinding the allocation. So we don't just blind the participants to what group they're in, but we have to blind our researchers so they don't know which group allocation is coming up. Put bluntly, if somebody shows up in your lab and let's say they've recently gained a bit of weight, and you think, oh, they're likely to bounce back and respond well to a weight loss intervention, you can't have your researchers say, I'll randomize you next week because I think I've got some exercise group allocations coming up. So your researchers on the ground You know, they're normally smart people, you'd hope, doing these kind of scientific studies. And they just sometimes quite innocently can't help themselves just thinking, well, you know, there's been 3 people in the placebo group. I bet the next one is going to be the treatment group. Blinding is a lot of fun as well, whether we blind the participant, as I mentioned, the allocators, the experimenters, those running your blood tests, those doing your statistics. And it's really important that this is all reported so thoroughly in a paper. Who generated that allocation sequence? Be very clear about who was blinded. And the key thing here on blinding is that we must verify that. We cannot describe a trial as double blind because you didn't tell participants which group they were in. It's only blind if they don't know which group they're in. And there's so many trials where, again, specific to kinesiology, athletes know how they feel when they get caffeine. They tend to drink a lot of it. Athletes know how sugar makes them feel on the bike. So if you're doing a blinded trial where you didn't tell them whether they got caffeine, a lot of them know if they were in the placebo group because they get a blinding headache from caffeine withdrawal. So it is important to report the success of that blinding for everybody. And the way that I often recommend to do that and to report it simply is with a 3-question exit questionnaire. And these questions are yes/no answers, and they sound like they're all asking the same question, but they're not. So the first one, if I remember, is just, could you detect any difference between treatments? And see how many people say yes. Then, do you think you could identify which one was the intervention and which was the placebo? Yes or no. And then, did you get the intervention today? Yes or no. And because often people think they can detect a difference, but then they don't know anymore, or they actually don't know which one was the treatment. So it makes it easy to report how successful that was for everybody. And the other couple of papers in this series then covers exclusions and dropouts. Doesn't matter if you've tossed a coin and got a perfect randomization. If your participants are not withdrawing with randomness between the 2 treatments, which they normally don't, then you don't have a randomized sample of completers. And this last paper is quite nice because it reminds us that you shouldn't be attempting to get equal group sizes in your experiment. And just about anything you do to try and make sure they're equal is going to really compromise your random allocation. So often if I see a trial that's got 3 equal groups of 50 and says it's randomized, I'm thinking, I bet it wasn't. Yeah, so are there any questions on controls, randomization, blinding, or again, just comments or suggestions of what I should be doing to control better for menstrual cycle?
I think, James, I can send you the chat after. I'm not sure you've seen it. I just put a link to a YouTube discussion we had on this very topic quite recently. It's such a minefield. But I think really the thing with menstrual cycle, I think that there's a risk that we're going down the road of it's so complicated that we just avoid. So we're kind of inadvertently contributing to this kind of sex bias in this type of research. But I think that something that we came to it a lot of the time is always very much the potential effect of the menstrual cycle versus the potential effect that you're looking for, because it's possibly a lot smaller for a lot of things than maybe we think, in which case maybe we have more leeway. Of course, if it's, say, a specific biomarker that you're looking for and you know that those hormones are going to impact, that's a different story. But I think in most exercise trials, exercise outcomes, it's pretty small. Kirsty Elliott-Sale also led a great paper on that recently, methodological considerations for working with female participants. So I can share the link here. Anyone, any questions, comments, suggestions? There's so much to talk about here, particularly that blinding thing. I see Brian is here. This is a conversation we have quite a lot about how best to ask, when to ask, that kind of thing. Sorry, I'll shut up. I tend to ramble.
I can see the chat now too, if there's anything comes up there.
Yeah. So
can I just quickly step in then?
Absolutely.
Hi, James.
Hi, Brian.
Yeah, it wasn't actually about sort of randomization and blinding, although, as you said, Emer, quite interested in that. I wanted to know your thoughts, James, on sort of, again, on controls. You mentioned their sort of menstrual cycle phase. I think sometimes sort of people almost maybe go overboard on trying to control things like diet, sleep, exercise, alcohol, caffeine. etc., that maybe sometimes we almost maybe go too far the other way, and we're almost moving away from what a real world setting is, when, you know, an individual, and one day he'll have one kind of diet and another day he'll have another kind of diet. I just want to know sort of your thoughts on, do you think we can go too far with these kinds of controls or not?
Yeah, definitely. So, and I think that the equivalent there to the menstrual cycle, the same principle stands. This is why in so many of our studies, we do within subject controls and ask the person to eat the same for 2 conditions, crossover trial, so that you've got comparable data there and there's no confounders in the experiment. But what we don't tend to do is have everybody consume the same diet over the 2 days before, because then that may or may not reduce the noise in your experiment. But what it definitely does is means that your entire experiment is now specific to the conditions of, you know, it may be that your supplement only works if they're on a high carbohydrate diet, which you gave them. So I actually prefer to let the participants do their normal thing, as it were, for the days before, unless it's something that you really think this will completely confound the study. So I do tend to make sure they've had a decent night's sleep and insist on that before exercise trials. But we've stopped, for example, saying no caffeine the day before, because I don't believe having caffeine day before has a big effect, but I believe not having it, if you normally do, probably is more of a confounder. So yeah, we do like to let them do their normal thing as much as we can.
James,
I
just
agree
to follow up on that. Oh, sorry. Go, Brian.
No, go for it, Emer.
God, I've lost my train of thought now. To follow that, when you say you ask them to make sure to have a good night's sleep, what actual instructions do you give there? And do you monitor that in any way? Do you use any kind of, I don't know, sleep questionnaire? You know, it's easy enough to tell somebody have a good night's sleep, but whether they actually have that good night's sleep, I suppose, is a more difficult thing.
Yeah, it depends. It depends on the studies, to be honest. So if it's an exercise study where I don't anticipate that staying up all night would have a terrible effect, we just tend to give general instructions that, you know, get an early night and stay rested, ready for tomorrow, and people tend to know what that means. For we do a lot of circadian research in my lab, where we have people coming in to stay the night and then test the next day. And for those studies, actually, we specify that they have to get up within a certain 1 hour period for a week. They have to go to bed within that period for a week, and they have to get light exposure within half an hour of waking. So with those ones, we really take it as far as we can to make sure we've got a nice stable rhythm before they come in. I can see one of the questions in the chat here is about whether the journal now requires the submitted checklist. Yeah, the other editors were kind of discussing whether we should ask for this, because they didn't want to put people off submitting to the journal because of having a checklist required. So I believe you can still manage to submit to the journal without including the checklist. But the way we tried to make it, or I tried to make it, was as easy as possible. So it's a Word template, and when you've written your manuscript, you just scan through and write, list, just like with the consort, list the page numbers that each thing's on. So it's more of a checklist for you as an author than for us as the editors, because it helps you just double check that you've included all the things that we'll be looking for.
Have you noticed any difference in reporting since implementing this, or is it too early to tell? Yeah,
I've noticed an improvement for sure. Nice. And I see every paper that comes in. I've kind of, since I took over the journal editoring from Ron Morn a few years ago, the number of papers coming in has gone down. But I think that's because of my approach has been to be a lot more fussy and accept far fewer papers in the end. But I think this checklist has helped with that. Just read. Oh, there's a lot of comments coming now. Shall I go on to the next section and then we'll come back to the questions? Shall we do that? So this last part,
a good idea.
Yeah. So this is the last main bit on analysis: reporting order, effects, and within group. So I've got a couple of simple slides to show on order effects and within group. On reporting, the two things I can just say on this slide that I really feel quite passionately about, top of the list for me is reporting individual data. You know, we've talked already about how sample size is a challenge for us, either because athletes are hard to come by, people willing to do these studies are hard to come by. So because we don't have 1,000 and 10,000 people in our studies, that has downsides, but it also brings opportunities. And what it means is if you have a study with 1,000 people tested twice, you really can't put the individual data spreads so easily on a graph. But if you've got 10 or 20 athletes tested twice, don't just do the kind of box plot. I mean, definitely not without a standard deviation at all, but even just the box with an error bar. Why not plot those individual data points? Why not pair them up between trials? Why not, if there's males and females, use a different symbol for each one? And that means people can then look back to the study and they can do further analysis that you never thought of even. So I'm a big fan of including the raw data, the individual data on the graphs. With my own research, I always make sure to make the actual raw data available in a repository as well, and people can go and analyze that if they like. And the other advantage of that is all these big decisions about what statistics you do. I found that really disconcerting as a PhD student when you've like put your heart and soul into doing an experiment, you love it and you feel like, okay, this is what we found. And then you hear statisticians talking about how, well, the stats technique you used has now gone out of favor and there's a new one, or no one really knows what the best one is. Well, if you've actually reported the raw data and based your interpretation on the data, not the p-value, then no one can ever change that. Your numbers were your numbers. You calibrated, they're valid measurements. So that stands forever. And if someone wants to come along in 10 years and do some fancy new version of a stats test that you hadn't thought of at the time, they can do that. So individual data reporting is something I think is important. Reporting with appropriate precision is linked to that. I think the record this year is I've seen age in years reported with 4 decimal places. So presumably those researchers measured people's birth time to the second. So you really need to convey the necessary and appropriate level of precision in your reporting in a study. And I mean, age, years isn't even a decimal fraction. So think about how many decimal places go into everything that's reported in a paper. Right, the last couple to talk about then, order effects and within group contrasts. These are close to my heart. These are the two main statistical glitches that I see that I end up referencing back to authors at the journal, but also recently I did a review of all nutritional supplements for performance and found that there were many specific nutritional supplements for sports performance where you take 10 papers that are out there and the balance looks like 9 of them show an effect, but actually 8 of those 9 papers have fallen foul of these issues with order effects and within group contrasts and really don't show effects. So on order effects, if we just make a mock experiment here where I'm going to have you come into the lab, 1 week you're going to have a load of alcohol before you come in, and 1 week you're going to have a control, alcohol-free vodka or something. And this is a strange experiment because when you come into the lab, a bell will ring, and at that moment, this wouldn't be ethical, but I'm just going to bop you on the nose. So as soon as the bell rings, I go to bop you. It's going to take me 150 seconds to react. So that's the green line when I start swinging for you. And we're going to measure how long it takes you to react. And I don't know, this is about how fast it takes to bop someone on the nose. So kapow, you're getting bopped on the nose at 250 milliseconds if you don't dodge. Well, now here's some purple dots for 5 people who came in week 1 in the control group. So they're fully sober. But you don't know it's coming, right? So only 1 person dodges and 4 out of 5 of them, unfortunately, I can only apologize for bopping you on the nose in this hypothetical experiment. Those who'd had all the vodka, unsurprisingly, have slower reactions. So all 5 of them get punched on the nose. But what we're trying to explore here are order effects, or some call them period or sequence effects. So you all come back in week 2 to do the other treatment. So let's just imagine this. I mean, this is a kind of a amusing example. I could probably have thought of a more serious one, but this is maybe more memorable. So those of you who did the alcohol in week 1, say the red dots in week 1, you come back in week 2, stone cold sober, but you do remember that you got bopped on the nose in week 1. So now when you hear that bell ring, you all duck and only 1 person out of 5 gets bopped on the nose. Whereas those of you who were sober in week 1, coming in week 2 knowing full well what's going to happen, but you've had your vodka this week, so you're still too slow and get thumped. So essentially this stupid design I've come up with is just an example where we might expect not only an order effect, because you can see on average, week 2 is quicker than week 1, but it's an interaction between the trial order and the condition, i.e. you only get quicker in week 2 if you had alcohol in week 1. And this is a nightmare to deal with. And this happens in so many trials. Imagine a less ridiculous trial is a performance trial where athletes come in the second trial, and if you haven't blinded them to their performance in week 1, they all try and beat their previous best. And sometimes they can only do that if they're getting the magic juice in week 2, which was your treatment. So this happens quite commonly. And either order effects aren't mentioned in the study, or researchers just test week 2 versus week 1 and say, there's no difference. But none of that gets to the heart of this order effect. I mean, the worst that I've seen is sometimes researchers will say, well, you know, week 2 here is about, I think it's about 300 milliseconds faster than week 1. So we'll just add 300 onto everyone's week 2 score. Well, that's not fair for the guys who did control in week 1. So there really is, I mean, the statisticians present 2 or 3 different methods to try and account for this, but really they're all so bad and there's no agreement that the only thing you can do is to allow an adequate washout between trial 1 and trial 2, or use fully familiarized participants. The big misunderstanding out there is that a randomized counterbalanced trial does absolutely nothing to prevent this. Look, I could tell you this is a randomized study. It's perfectly counterbalanced because 5 did one and 5 did the other in week 1, and you still get the order effect. So randomization and counterbalancing does nothing whatsoever to prevent order effects or an interaction between order and treatment. So you have to have an adequate washout or familiarize your participants for this. Or if neither of those are possible, do a parallel group comparison. Just compare the week 1 data between groups. And then quickly moving on to the second one then is these within group contrasts. I probably quote these 2 papers from Bland and Altman to more authors submitting to the journal than I do for any other comment that I give. And what these papers are pointing out is that we should always base our comparison, whatever statistics you do, they should take into account your control group. That's why you've tested that control group, right? That's why randomization was so important. So if you find that your analysis could be done without even having tested a control group, that's the clue that something has gone wrong here. The example data set I could use would be something like this. I haven't even imagined what the trials are, but here we have the red group who pre to post have a very small change, but it's significant, right? Tight standard deviations, that's a very consistent response. And let's just say it's significant if we want to inappropriately use that whole significant, non-significant comparison. But the purple group, despite the fact that they increase a lot more and end up higher at the end, there's so much noise in that response, that happens to be a non-significant outcome. And so many reports, particularly in the sports nutrition world, I could list a range of supplements to you where the balance, the majority of published papers have a conclusion in the abstract that says there was a positive effect. But all they've shown is that the post-supplementation score is better than the pre within the supplemented group, but was not different to the control group. So you can't say this is significant, that was not significant, therefore they are different to one another. Mainly because not significant doesn't mean the same. It just means you couldn't detect the difference. So yeah, we can discuss that, I suppose. I don't need to talk much more about it. So yeah, on those last couple then, randomization, blinding, controls, reporting, order effects of within group. Are there any comments and questions on that? I think, what have we got, 5 minutes left? We're about there.
So guys, I think we've got a few questions in the chat here from a little bit before, but also in comments. And if anyone wants to unmute and ask on those last ones as well, like there's so many things. James, I love your experiment example of the bopping on the nose and the alcohol.
Yeah, it always, I keep it in mind because it helps me remember it.
It stands out well because I think I hadn't, it's something kind of peripherally aware of, but find it difficult to put in my own head. That's a nice one to just clarify and solidify that. Where are we? Sorry, I'm looking at the chat now myself. There's a comment from Gabrielle here about blinding with caffeine. Assessing what participants think they had for treatment is important and could be adjusted in statistical analyses. Placebo, nocebo component could always be there, even when the participants get it wrong. I think that's a very interesting one in that. Yeah. Just what people think they're getting.
And on that, I think I'm okay to name and shame or name and credit. It was Trent Stellingworth on the editorial board who helpfully suggested belief is an important one too, because you could think you're getting caffeine, but if you really don't believe it helps, it probably won't, or maybe it won't if you don't believe it. So you could also ask whether they think that it should help.
This is well, sorry, Brian, you're still on my screen there. Brian Saunders has done quite a lot of work in this way in terms of the power of expectancy and how much it can influence. So I think definitely a huge factor and going to be the topic of one of our upcoming discussions as to both the challenges and the opportunities of expectancy belief in this type of research. So I think it's, when you start digging in there, there's just so much to unpack. This question from Rosie here, James, any thoughts on the potential to do a meta-research project in terms of looking at reporting pre-post implementation of the guidelines?
The answer is no, not because there's not an appetite for it or it's not a good idea, but I'm just thinking that would probably be a mammoth amount of work, right, to kind of work out whether each paper, but especially because you'd be, I suppose if we were only focusing on the ones that got accepted, it's a smaller number now, but it would be very difficult to go through all the previous papers and work out which ones were previously rejected for these things. So yeah, if you're volunteering, I'd happily work with you on it, but I'm not going to do that myself.
Well, maybe a STORK project. If members wanted to come together, but yeah, I agree, it'd be a huge one, and also there'd be an interesting thing there of there's going to be obviously be major bias in the published articles because you're choosing the highest quality. So whether everyone, you really would have to go back to the rejected ones as well, which is obviously difficult. James, is there anything in IJS-NEM? Sorry, another question from Rosie here about encouraging data sharing or data availability statements. I
can't remember off the top of my head whether we put anything like that in Present or in our guidelines. I hope we did. And if we didn't, I will go after this meeting and check, because like I said, I do that with my own research. And we certainly have papers submitted that provide a link within their paper to a repository where they hold the data. We don't keep the data ourselves like some journals do and have it available. We leave it to authors to manage the data set.
Guys, we're just coming up on the hour here. James, I'm conscious of time, but if anyone has any last questions, comments, suggestions, I think we could probably take any one of these things and have a couple of hour discussions. But yeah, sorry, if anyone has any final questions, comments, suggestions, now's the time. Oh, I think everyone's thinking. But yeah, overall, James, thanks so much. That was so interesting. There's so much to unpack here. I've been, as always, scribbling in my notebook throughout, and really appreciate you taking the time. I think that was such an interesting talk, and really these factors have so much potential to increase the overall research quality of what we all do. If we all understand what we're all doing, it just has so much potential to impact our kind of collective research efforts. So we really appreciate you taking the time to come here today and talk to us about your experience.
Yeah, thanks for inviting me along. And like I said, it's a really noble cause, so I'm happy to contribute. And I hope to see some of you, meet some of you in person sometime once we can all actually move around again. So yeah, have a good evening, morning, whatever time it is, wherever you are.
I think we're all spread around the way. You've actually given me a good segue here to guys, just anyone who is following STORK on Twitter or our members, if you were willing to fill out a brief scoping survey that we've just circulated, we're hoping to plan an in-person meeting next July in California, which will be all things research methods in our discipline. And as I say, we've just circulated a brief survey. Really keen to get feedback. The more comments and suggestions we can get, the better we can plan something that is kind of aligned with people's requirements and preferences. So if anyone spots the link to that survey, please feel free to fill it out and also retweet, share, tag. Let's get as many responses as possible. So yeah, I think, James, we'll leave it at that. Thank you again, really appreciate it. And I'm going to stop recording now. Cheers, everyone.